Hi, I'm Kathy Levinger. In this lesson we're going to look at some examples of solving problems. Let's look at this one to begin with. Christine is building a tower with her blocks. The table below shows how tall the tower is for various numbers of blocks. And what you see in the table is the number of blocks, 3, 6, 7, 10, and the height of the tower in inches, 2.25 inches, 4.5 inches, 5.25, 7.5. The first thing we want to do is use the table to write a model that gives the height of the tower as a function of the number of blocks used. To get to that answer, let's follow through the INVESTS procedure that's outlined in your textbook. To do the I part, or identify, and perhaps the N part too, of the INVESTS procedure, identify and name, let's let N be the number of blocks. That's identifying and naming a variable. And let's let H be the height of the tower in inches. So we've got our INVESTS, or the IN part of our INVESTS. Now the V part is to come up with a verbal model that describes what we're trying to do. And so we could write something like the height is equal to the number of blocks times, let me put that in parentheses, times the height of each block. Height of each block. And so there's a possible verbal model. The height of the tower, maybe I should write that underneath. The height of the tower is the number of blocks used times the height of each block. Now it's not really written that each block is the same height, but we'll make that assumption. Let's do the E part of our INVESTS procedure, which is to write an equation. Now we have the height of the tower is equal to the number of blocks times the height of each block. But I don't know what that is, so let's use some information in the table. Here's our table to find the height of each block. Notice that 3 blocks have a height of 2.25 inches. To find the height of 1 block, we take the total height of 3 and divide that by 3 blocks. And let's see what that comes out to using a calculator. We'll take 2.25 divided by 3 and get an answer. And the answer in the calculator comes out to 0.75. That's the height of each block. Filling that into our equation, we can say height is equal to N times 0.75, which actually makes more sense when written H is equal to 0.75 times N. So there's our equation. Now the next part of our INVESTS procedure is S, or solve. Let's look at what we want to use our model to find. We want to use our model to find the height of a tower if 8 blocks are used. So let's see. H is equal to 0.75 times 8, putting the number of blocks in. Again, using a calculator to simplify, we can do 0.75 times 8, which comes out to 6. Now, the units on our answer are inches, and so we should write a sentence. The height of the tower is 6 inches when 8 blocks are used. Now the other parts of the procedure, actually S is, this is the other S part of the procedure, write your answer with a sentence. There's a T in there, which is to test our answer. Well, we got the answer for 8 blocks, 6 inches. Let's just look at the other information in the table. 7 blocks were 5.25 inches, or the tower was 5.25 inches. 10 blocks was a tower of 7.5 inches tall, 8 would be closer to 7 than 10, and 8 came out to exactly 6 inches, which is 1 block, or 0.75 inches, more than 5.25. So our answer tests very well according to the information in the table. Let's try another example. Jenny is training for a triathlon. In the table below, she recorded the number of hours she trained on successive days and the number of miles she completed for that number of hours. Remember that a triathlon is swimming, biking, and running. And so it says in our table that when she trained for 2 hours, she completed 38.7 miles, for 3 hours, 58.05 miles, and 4 hours, and so forth. We want to use the table to write a model that gives the miles as a function of the number of hours trained, and then we'll worry about answering the other questions involved here. Well, let's start by identifying and naming some variables. We've got numbers of hours. Let's let n be the number of hours she trains, and let's let m be the number of miles completed for the different numbers of hours trained. So we've got those two parts of our invests procedure. As far as a verbal model, a description of what's happening, for each number of hours, she completes a number of miles. So the number of miles is equal to the number of hours times the number of miles per hour. So let's write in words number of hours times, I'm going to write number of miles per hour, MPH for miles per hour. And now we're ready to translate that information to an equation. Let's see. Our equation might look like miles equals number of hours times that unknown thing, which was the number of miles per hour that we don't know. To get the number of miles per hour, we're going to have to use information in the table. Let's pick an arbitrary piece of information, like for 4 hours training, she traveled 77.4 miles. We take 77.4 miles and divide that by the number of hours, and let's see how many miles per hour that is. However, we should also check all the other parts of the table to make sure they match this number of miles per hour. So let's pick this second bit of information and check it out also and make sure that's the same number of miles per hour. So let's see. On a calculator, we want to find 77.4 divided by 4, and that number comes out to 19.35 miles per hour. That's not just running, that's biking and swimming also. So let's try this next bit of information, 58.05 divided by 3, and that also comes out to 19.35. And as long as I have my calculator out, I can try 96.75 divided by 5, that's 19.35. 38.7 divided by 2, that's 19.35. And I'll take a minute to show you those calculations. And you can see that the number of miles per hour is consistent for this particular case. So now we're ready to complete our equation. We can write that the miles are equal to the number of hours times 19.35, but that should be written 19.35 n is equal to m. So we've got an equation. Now we're ready to solve or answer the questions asked that go with this model. The first thing we want to do is find the number of miles covered on a day in which she trained for 4.5 hours. So let's see, how many miles if she takes 19.35 miles per hour times 4.5 hours? Well, let's grab a calculator and take 19.35 times 4.5. We end up with 87.075. Let's round that to 87.1. We'll say approximately 87.1 miles were covered when she trained 4.5 hours. Well, there's another question here, and we should take a look back at that. The other question says, how many hours has she trained on a day in which she covers only 10 miles? Well, in that case, the number of miles, here's our equation here, that we're going to use is 10. And if we want to solve for n, we're going to have to divide each side of the equation by 19.35. And we'll grab a calculator, and we'll continue this way, and we'll find 10 divided by 19.35, and that will be equal to n. 10 divided by 19.35 is 0.5167 and so forth. Let's say that's approximately a half an hour. It's a little more than half an hour. Half an hour, and she trained for 10 miles, or she covered 10 miles in her training. Well, each of these answers needs to be written with a complete sentence. So let's complete our sentences here and say, when she trained for 4.5 hours, she covered 87.1, I think, miles. When she trained only 10 miles, it took her approximately half an hour. And so, not half an hour, half an hour. And so we've completed our problem by writing complete sentences. We should test that T part of your invests procedure, our answers, and we'll do that by looking at the table data and making sure that those are sufficient. Well, let's see, 4.5 hours falls between 4 and 5, and the number of miles is 87.1, and that fits very nicely in our table. Half an hour goes with 10 miles. Now, we only have, or our table starts with 2 hours, but 10 miles seems reasonable if you think about that 19.35 miles per hour that we found for her. Let's try another problem, but this time the information is not given in a table. Andy's doing a research paper for English class. He can type approximately 58 words per minute, and it takes about 2 minutes for the printer to print most documents. Write a model that gives the total number of words he will produce as a function of the number of minutes he works. Let's stop there and come up with a model. We'll be a little bit less formal as far as our invests procedure, but we're definitely going to start by identifying a variable, some variables. We want to write a model that gives the total number of words he will produce as a function of the number of minutes. So let's let M be the number of minutes he works. And we'll let T be the total number of words he'll produce. And for the total number of words to be a function of the number of minutes, we need to use this information that he can type 58 words per minute, but it also takes about 2 minutes for the printer to print. Now that's not actually his working time, but in a sense it is, because he has to wait for the printer to finish. And so we can say that T is equal to 58 words per minute times the number of minutes plus the 2 minutes that he has to wait for the printer. And so here's a model that will be total number of words as a function of the minutes he works. Now let's use our model. It says if he types for 2 hours, how many words will he have typed in his paper? Now in order to use the information 2 hours, we're going to have to translate it to minutes. So we'll use 120 minutes. And we'll say T is 58 times 120 plus another 2 minutes. And we'll grab a calculator and see how many words that is. We'll do 58 times 120 plus another 2, and that comes out to 6,962 words. Well, there's another question here. The next question says, if he waits until the last 30 minutes before the paper is due and starts to work, how many words will he be able to include in his paper? Well, let's see how we can answer that question. If he has only 30 minutes to work and it's going to take 2 minutes for the printer, then he's only going to be able to type for 28 minutes. So the total number of words is 58 times the number of minutes plus 2. But the number of minutes he'll be typing is only 28. So we'll take 58 times 28 plus 2 and grab our calculator and find 58 times 28 plus 2. And the total number of words he'll be able to include is 1,626 words. Well, in this lesson we've tried some different word problems with different approaches to organizing the work. Be sure to work some exercises from your book for practice.